that proper length to be? We know it's 4.3 light years. The astronaut's perspective is, yes, the Earth is apparently moving away because they don't know that they're actually moving themselves, but they get the same reference point. There's this new length that the astronaut is actually travelling. So when we look at that length from the Earth, it's no longer that distance. It comes down substantially, and we have to have a think about that as well. We talked about the time when we're measuring the astronaut scenario from the Earth. Notice that time interval there is greater than what we consider our proper time. So it's a matter of how you see those two things to what your brain is trying to process. Let's just see what our strategy is here. First thing here is units, because we haven't talked before about the length of a light year. Now, a light year is 300,000 kilometres a second for every second in a year. That'll give you a distance. So a light year is a distance measurement. And it will be convenient to use that, and we will go through. So in part 1, note that the 4.3 light years distance from Alpha Centauri to the Earth is a proper distance, and because it is measured by an earthbound observer to whom both the Earth and the star are basically stationary. To the astronaut, the Earth and Alpha Centauri are moving by the same velocity, and so the distance between them is contracted. So when you're on the spaceship, the actual distance you will travel will be less. In part 2, in solving this, we are given the gamma value of 30, and we're just going to do a bit of rearranging to try and come up with the right answer for that one. We're going to identify a couple of unknowns first of all for a strategy for solution to here, and we've come up with that we've got from the question, and the gamma part for part 2 we've got from there. We then choose an appropriate equation. We're trying to work out the length value that the astronaut is experiencing. We know the proper length we measured is 4.3 light years, and we know the gamma conversion value when we substitute into that for the velocity. They've told us, they've done the maths, it comes out 30. We do the maths and we find out that what we perceive to be 4.3 light years from our Earth perspective, when you're on the spaceship, it's actually only 0.1433 light years.